Hi guys, and welcome to the next episode. Today we're going to take care of the tool frame. So I hope, as you remember from my last video, we were talking about frames, to be more exact, about the word frame. And I want to go back really for a brief moment to that video, just to remind you what the frames are. So they are used basically to describe the position in a three-dimensional Cartesian system. So you have your x, y, and z coordinate, and yaw, pitch, and roll orientation. So that's just a reminder, and now let's get to the tool frame. Okay, so what is a tool frame? It is used to describe where the end of the arm tooling, actually where the focal point or reference point of the end of the arm tooling is. So by default, it is located at the end of axis 6 at the front of the robot faceplate. So you have we can imagine a small dot that's being placed over there, and that's the point that you will refer all of your movements to. So when you're going to jog using the tool frame, you will refer all of your movements to that dot. So you're going to rotate around that dot, you're going to move forward, left, upward, whatever, according to that dot. That dot is going to move or won't move. So to describe it better, what is it and why we use it? So let's say you have a spot welding gun mounted at the robot. So why do you need the tool frame for, or TCP as it's called? So what it's doing basically is a physical measurement of the distance from the robot plate to, for example, if you have a welding gun, to the electrode. Or if you have a MIG torch, it's going to be from the faceplate to the wire stick out. Or if you have a gripper, it's going to be from the robot faceplate to, for example, a pin or one of the clamps on the gripper. So you will have a point of reference for the movements. So you know what's going to move. So you don't need to look, well, you need to look at the whole robot, but while jogging, you're going to just take a look at that small dot and where it's moving. So that's why you create it. So it's easier to operate the robot. It's easier to grab the part. It's easier to go and make a resistance or spot welding point. It's for you to be able to use it more efficient, the robot. And also it affects the positional data. So the positions that you have, that you know, that when you get the welding gun, for example, inside the part and you stop, you know the exact distance from that point, which is going to be your TCP. So for example, end of the welding cap to the robot base. Or from if you're using the user frame, which we're going to talk about later, from that TCP point to the user frame 000. And how to describe it even better? So let's say that's the robot faceplate, right? So right here you will have the coordinates 0, 0, 0 in the XYZ and 0, 0, 0 in the orientation. Which means basically that your TCP is located at the robot wrist. Now, let's assume you're attaching a tool to the robot. That's going to be the hand in my case. And right now, you want this to be your TCP. You want to rotate around exact this point. So you need to measure from here the distance in the Z direction and then the distance in the Y direction. Because when you take a look at the orientation of the basic tool frame, so the tool frame that's located on the robot flange, it looks like this. The Z goes up. That's why I said it's in the Z direction. Still, the right hand rule will apply, so don't worry. And why do you need it? Because also the robot needs to know, you can imagine, you need to know where to move. There is a exercise that sometimes you do. You close your eyes, you take your finger and you point to the nose, and bam, you hit it right into the nose. How you did it? Because you know where that TCP is located, right? You can calculate in your mind like the distance in here, and you can imagine that you're moving to the nose, right? Pretty simple. That's why you're creating your TCP, to know what you're going to move, how you're going to move it, and also to give the positional data for your programs, so you know where the robot is located in each place. Because sometimes it might happen, for example, that let's take a look at the spot welding robot, resistance welding. Sometimes you're making the points and the welding engineer will come to you and say, whoa, 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 those points are like 5 millimeters off, or like that point needs to be shifted 3 millimeters to the left, 2 millimeters to the right, and so on and so on and so on. And to do that, you can either take the robot, move it to the position, and then jog. But which way to jog? Okay, if the robot is located like right in front of the car, it's easy because you can use the word frame. But if it's rotated in some different way, you need to jog the gun inside, and you're going to use the tool frame probably to jog it in. And if you want to know the correct coordinates of the point and which way to move it, you need to know your tool frame and your user frame. In that case, your user frame will be more important to shifting the points, but that we will cover in the next video. So I hope you kind of know what I'm talking about. We can go to more extreme case. So imagine I'm only going right now to talk to the men's side of the audience. Imagine you're going to the restroom at the bar and you're gonna, take a leak. And that's also your TCP, right? You need to know where to aim, and you know the distance, of course. So that's what I'm talking about. That's the TCP. It's like telling the robot or telling to yourself which point you're going to move, which point you're going to rotate, what's going to happen when you push this or that button. So for example, for the picking the part, right? When you take the part and you have your gripper like this, it won't fit to the part, so you gotta rotate it. You need your TCP, so you can rotate around that point. And that's what the TCP is for. How to teach the TCP, or how to tell the robot where the end of the arm tooling is, where the TCP is, where the tool frame is. We have a few methods. We have 2-point method to teach it. That's used only for the 4-axis robots, so we're not going to talk about that. But we have the 3-point method, 4-point method, which is something new. It's not on the older robots. We have those two are going to tell you only the X, Y, and Z distance. It won't change the orientation. So if you have a tool that's mounted on an angle, so let's say that's your wrist, right? And your tool is mounted like this on a 45-degree angle, you won't tell it to the robot. It will still try to move with the orientation located the same like in here. So you gotta also change the angle on your TCP. And for that, you're going to use the 6-point method. There are two 6-point methods, X, Z, and X, Y, depending on which plane you want to teach. And we're going to get to the exercise in a moment. So those are the ways, and there is also a direct entry, which is probably least accurate unless you're using a laser tracker that's going to tell you exact the position, because usually that data you're getting from the offline, or it can be accurate if you get it from the CAD simulation. It depends. I use it often on the big projects when you have, 100 robots. Nobody is going to measure the TCP, you will just check it, verify it if it's in the right place, to make sure your programs are correct, to make sure later on your positions are correct, and it's easy to use. And it is crucial because we're going to talk about stuff later on, like position registers, offsets, and so on and so on. And it's super important to have accurate TCP so you can offset those points. But that's later on. Okay, so let's get to the exercises. I'm going to show you how to use all of those methods except for the 2-point method that I told you, because it's used only for the 4-axis robot and we're not covering that, actually not right now, maybe later on. So give it a like if you want to continue, subscribe, and let's do it. Okay guys, so let's get to the exercise. As you can see, we have our robot. It has a nice tool that we're going to use, a nice pointer that we're going to use to teach our TCP. On the table also we have a pointer that's great for teaching the TCP. I guess normally you will never have that kind of a setup, but you gotta create it somehow. So let's get to it. So basically, first thing I want to show you is when you're going to select your tool frame and on the robot, and it will show that you have the tool frame selected. In the robot guide, you will see the visualization of your current tool. And as you can see, we have the Z pointing down, the X pointing to the left, and the Y pointing in front of the robot. So you can apply the right hand rule right here, and you see how the TCP is located when it's not taught. Basically, it's mounted, it's attached to the robot flange, like I said, to the 6-axis, and that's how it looks. What we want, we wanted to have it right there on the tip. And how do we do it? So let's get to our teach pendant. So let's turn it on. We go, like always, menu, we go to setup, then we're going to select frames. In my case, it's here. And in case I'm already in tool frame, however, you might not see it. So you gotta hit other and select the tool frame. So we're going to use tool frame number 10 today. So go to tool frame number 10, just hit enter. And here it is. As you see, it's 00000, so that means the TCP right now is located at the flange, like I've said. And what can you do? First thing that you should do is name it. So when you are at the comment section, just hit enter and type the name, whatever you want. I'm going to use the keyboard here, and I'm just going to type pointer. So we have the name. Always name your TCPs, so later on when you have more than one, it's easier for somebody to find the correct TCP to jog in. So like I told you guys, when you hit method, you're going to see all of the methods that are possible. So we have 3-point, 6-point, XZ, 6-point, XY, 2-point, Z plus, 4-point, and direct entry. So basically, the difference between the 3-point method and the 4-point method is that we're teaching one more point, but the 4-point method is going to give us the mean error max error. So that's something new. Well, not entirely new, but pretty new with the FANUC. That option was not available before. So I highly recommend using that one instead of 3-point, but if you don't have the 4-point method, 3-point method works perfectly fine. However, I'm going to show you the 4-point method because the logic behind it is exactly the same. So let's select the 4-point method, and you're going to see that you have 4 approach points that you need to teach. So how that works, pretty easy, guys. You need to jog the robot. To be more exact, you gotta jog that tip, the end of that tip, to the end of the tip in here. Get it as close as possible. Using the robot movement. So what I recommend for you guys, start with the world coordinate system and just simply jog the robot slowly to where you get it as close as possible and work your way through so you can get really nice TCP.
I'm not going to do it right now using the jogging because it will take a lot of time. Why I told you to use the word? Because that's the coordinate system that you know. As you can see, it's changing here. If you don't know what I'm talking about with the coordinate system, check out the video that I made before on the coordinate systems. It is really helpful, and it will help you to do the job easier. So as you can see, as I changed to word coordinate system, our coordinate changed. So the Z plus is pointing upwards, X is pointing out of the robot, and Y is pointing to the left. That's why I prefer using the robot guides than the regular robot guides, because some of the things will show in here and it's just easier for you to understand. However, I'm planning to make some videos on the real robots, so keep tight, and I promise there will be some videos showing the real robot. Okay. Because teaching all of these points will take some time, I already made the program. So let me go to it. So basically, like I said, you have the robot in some home position or wherever else. What you do, you just move the robot to the first point. As you can see, I get it as close as possible. So you can see that the tip is in the middle of the pointer. So that's your first point. So remember, guys, we want to have the robot TCP in here at the very end of the pointer tip. So we have our first point. So in the approach, we're going to record it. To record, you gotta hold your shift button and hit record. And it's going to say that the point was recorded. Sorry for that. I moved the mouse. Okay, then you have to move to the next point. You will ask, is there any requirements for the points, how they should be located? So guys, the FANUC is saying the best, each point should be offsetted at least 90 degrees. That's like the perfect solution. So the first point, as you've seen, was like right here. The second one is pointing straight, and the next one I have, I believe, on that side. I don't remember. But that's FANUC recommendation. Is it really necessary? Not really. Basically, the bigger the difference in the orientation between those points, the more accuracy you're going to get. Okay, so you're at the second point, the same story. You're going to hit your shift, you're going to hit record, and you're going to get the message that point is recorded. You got your second point. Let's go to the third point. So we're going to move to the third position. Again, align the zip to be in the center as close as you can, and let's record the next point. So again, hit shift, record, point recorded. Okay, and let's get to our last point, which is going to be point number 4. As you see, on my example, it looks pretty similar to point number 1, but like I'm saying, it's all entirely up to you guys how you want to do it. Like I said, the more difference between the points, the better. So we're going to record it, and guys, take a look what's going to happen in here, and take a look what's going to happen up here. So right now we're going to hit record, point recorded, and we got our point. That's the accuracy. Well, guys, if you're going to get that accuracy while teaching your TCP, awesome. That's like super exact. 0.06 millimeters of a maximum error. Guys, awesome. Really, you are very, very good. So what happened right now? Let's change our coordinate system to tool. And take a look. Right now we have our TCP moved, so it shifted from here all the way down to here. As you can see, we have now that dot in here indicating where the TCP is located. Regarding that, I'm going to show you, I got, I believe, 0.1 when I was doing the TCP with the needle, because I needed it for a really good accuracy for my vision. Because the project I'm on right now, I have a vision system, but the guys chose the wrong lens. So I'm struggling with the peak quality, so I needed to make the TCP and the tool frame super exact, so I use a needle. So when you have a gripper and you want to do a really good TCP and frame, use a needle. There is always a way. Just take a look at the picture. Okay, let's go back. So guys, what happened? So we moved the TCP from here to here. Let me select in other frame, which I believe is empty. Nope, it's not empty. Let me go really fast and check number 8, for example. There you go. So that's the TCP originally. So I'm right now using TCP number 8, and as you can see, it's located, like I said at the beginning of the video, at the end of the robot and the end of the arm tooling, or at the actually robot flange, and we will have the Z pointing that direction, the Y pointing to the, well, right now to the left, and X pointing out of the robot. Go back a little bit and you will see when the robot was in its home position. So what happens when you change to your tool, that we thought was number 10, it shifted, guys. It shifted from the robot flange up to here, up to the pointer, and what that is giving us. So take a look at what's going to happen right now when I jog the robot around that point. So right now our TCP is taught, and the best way to check if your TCP is accurate, you're going to select it, of course. So make sure that you have tool number 10, because that's the one that you thought selected. Select the tool frame from using the court menu, and try to jog it using the rotation. So right now when you jog it, you can see that the robot is rotating and making all of the movements, calculating all of the movements according to the TCP that you taught. So he's trying to keep that dot in one place and change its position to whatever it has to be, whatever you want to, however you want to jog it. So again, look, it looks really awesome with the real robot. I'm going to show you a video. So that's why you teach your TCP. Well, now I'm rotating around Z, so nothing is happening except for you, that you can see that the axis is turning around. So that's how it's done with the 4-point method. Now pros and cons. So right now my tool is located exactly like I want. So it's in the axis of the axis 6. So if that tool was located at 45 degrees, we're going to have some issues because you always want the TCP, you want to know how to move the TCP. So right now, if I'm going to hit Z minus, the robot will go up with the TCP, X plus, as you can see, X minus the other way, Y minus, and so on. So basically right now, guys, you need to imagine that you're moving that dot. That dot is the point that you will move whenever you hit the jog keys. But let's say you have an application and you don't want your Z plus to go down, but you want to do, when you hit X plus, that the robot will go down, so that will go towards the part. And there are two ways how you can do it. One way is you can change your method now to direct entry. So as you can see, the robot will keep all of the points, which is awesome. And what you want to do, you can play with the WPR in here in order to figure out the way. So basically we would need to rotate around Y, which is the P, for 90 degrees, if I'm not mistaken. And then our X is going to be pointed downwards. And there you go, there you have it. Now your X is pointing down. So right now, basically, when I hit X plus, the robot will move down. There you go. And your Z moves left or right. So that's the one way to do it, but sometimes you will have your TCP at an unknown angle. or at least you won't know it. So when you don't know it, or when you don't have the drawing from the CAD software that you can put the data in here, you need to use your 6-point method. So you have two, 6 points xz and 6 points xy. So let's use the 6 point xz because we want to change the z-axis. And as you can see, again, because you thought those points before, all is recorded, the only two things left is the x direction and the z direction. Let me just go back and get rid of our 90 degrees in here. As you can see, we went back. Let's open our 6-point method again. And so we have our orient origin point, which is recorded, which is the 4th point that we thought, but we're going to change it, but that won't affect the frame data, don't worry, because right now it has a different purpose. And we have our x direction and z direction point. So basically we're going to tell the robot, hey, when I'm going to hit x plus, you're going to move into that direction. Hey, when I'm going to hit z plus, you're going to move into that direction. So guys, let's do it. So first of all, you want to teach your orient origin point. So that's the point from where you're going to tell which way is the x plus and z plus. And that point is crucial. So basically what you want to do, you want to align the robot with the ground, or at least that's how I usually do it. So just make it 90 degrees to the ground. So how I do it usually, I go back to the program and I have a point thought, usually in a different frame, with the zeros in here for the y and z. So let's move to that point. Let's change the frame. Let's move to the to that point. Sorry guys. All right, let's turn on our tool so you guys can see that that's our tool. Yep, there you go. And let's select the world coordinate system. There you go. So right now I am aligned to the ground 90 degrees, as you can see. And that's crucial because basically you will set the orientation like this. I will show you later on why that's so important. So we have our point thought, and right now we go back to the frames, and we want to save that as our orient origin point. So we're going to do shift record, and we have, it says that point is recorded. As you can see, none of the data changed because again, we're saying, hey, from this point, I'm going to tell you where to move in the X and where to move in the Z direction. So like I said, we wanted to make our X plus to be going towards the part, so going down. So in order to do that, how I do it, I always choose the world coordinate system, and I'm just going to hit Z minus because that will take the robot down. And I'm going to say, hey, from this point, which is my orient origin, down means X plus for you. So let's do it. Let's jog the robot down. All right, you need to jog at least 250 millimeters in order for the robot to have a good frame. And you're gonna hit shift record, and we got our first point. Now we go back to the orient origin point. So we hit shift and move to. And now I want to tell him the X direction, which for me, the Z direction, which for me doesn't really matter right now because that tool is rounded. So I'm going to choose basically whatever. So I'm going to choose for the Z plus to be the Y minus direction. So I'm going to jog the robot in the world again, in the Y minus direction, 250 millimeters at least. And I'm going to do the shift and record. And there you go, guys. You have your new TCP calculated. So right now, when we go to our tool, number 10, let's check it. There you go. The X is pointing down. The Z plus points to the right. Y plus points to the points towards the robot. So when we're going to jog X plus, it will move towards the part as we want it. Now you guys will ask why there is a minus 19 here. is because I taught the Z plus to be in here. So that doesn't really matter for us again, because that pointer is rounded. So that doesn't really matter for me if the Z is going to be pointing right, pointing left, or pointing towards, or any other direction, because I'm not able to know anyway, because it's rounded all the way. But when you have the gripper, it will be important for you. So that's how you use your 6-point method. Basically, I hope you guys get it. If you will have something on the robot mounted on the 45 angle, guys, follow the same rule. Make it so it will look like this, so it will be parallel to the ground, and follow the same rule. You want the X plus or Z plus to be towards the part, do the same. So you move the robot, you teach it with a point like this. If you don't know the angle, because I knew that it's in the same angle as the axis, so I could create the point that I told you about, because I knew it's going to be 0, 0, 0, 0, and that one doesn't matter because it's just rotating around the X. So because you won't know that, how I do it usually, there are two ways. Either I'm going to take a level and put it like in here, and level it in one direction, then put the level in here, level it in the other direction, so I'm sure I am parallel to the ground with the tool. Or the other thing that I do usually is I will just take that pointer to the edge of the table in here. I will try to align it, so you know, it will look like this. It will be perfectly straight to the edge of the table, the pointer, so that will be aligned basically with the table in here, and that way I know that I'm parallel to one direction. Then I will take it to the other edge, so this one, and I'm going to make it parallel also in here. I hope you guys get it. If not, let me know. I'll try to do the exercise with the real robots, but as far as I know, I don't have anything mounted on a 45-degree angle, but I can come up with something if that will help you to better understand it. I forgot to mention about one thing in the 6-point method. I'm sorry, in the 4-point method, which probably we won't see right now. Let's go to the 4-point method. The max error that was shown here, it says add point and a point number. So that means basically that least accurate point for calculating the TCP was point number X. So you can go back to that point and teach it again. So like adjust it a little bit more, because you were a little bit off, and that way you're going to decrease the max error and of course the mean error at the same time, and that's how you get more accurate TCP. I would say that's it for now. I hope that you guys enjoy the movie. You can take a look why we teach the TCP. Here is the short video.
Okay, that's it for today. If you have any questions, please leave it in the comments. As always, please guys, give me a like, subscribe the channel so I know I can continue my work, and enjoy the rest of your day, have fun, and see you in the next movie. Bye bye.